When you're staring at a spec sheet that reads 72-core CPU, 810 gigabits per second SFP plus ports, hot swap power supplies, it's easy to feel the pull of the headline and wonder whether the hype actually translates into something you can use day to day. I've spent the last few weeks setting up the Mikrotik Cloud Core Router CCR1072 G8S Plus in a couple of very different environments, a small ISP lab and a research data center rack. And what follows is the honest take on whether that kind of horsepower is worth the price tag for you. Link is in the description if you want to check the product details on Amazon. First, let's talk about the kind of situation that makes you consider a box like this. The CCR1072 sits in a category that's traditionally been occupied by carrier-grade chassis from vendors such as Cisco or Juniper. Those platforms are built for massive throughput, dense routing tables, and the ability to keep traffic moving even when a line card fails. If you run a boutique ISP, a campus network that aggregates several 10 gigabits per second uplinks, or a lab where you need to throw 40 gigabits per second of traffic through a single device for testing, the CCR1072 is designed for that. It's not a plug-and-play home router that you'll mount on a shelf next to your Wi-Fi AP. It's a purpose-built chassis that expects you to have a clear need for raw packet processing capacity and the skill set to tune RouterOS for that environment. One of the first practical things I noticed when pulling the unit out of the box was how the 8 SFP Plus ports are each wired directly to the Telera 72-core processor. That means there's essentially no internal bottleneck. You can saturate all 8 ports simultaneously without the kind of queuing you'd see on lower-end gear. In the ISP lab, I connected 4 ports to a pair of 10 gigabits per second fiber links feeding a traffic generator, and the other 4 to a virtualized routing instance running BGP. The router handled full line rate on all links, and the CPU utilization stayed in the 20–30% range even when I pushed a mix of IPv4 and IPv6 traffic with a 10 gigabits per second burst. For anyone whose network design relies on keeping latency low under heavy load, that kind of headroom is a concrete benefit, not just a marketing number. The hot plug power supplies are another hidden strength. Each unit comes with 2 redundant, interchangeable supplies that you can swap without shutting the router down. In a production environment, that translates to real uptime. I tested the hot swap by pulling one supply while the device was processing traffic, the other kicked in instantly, and there was no packet loss observed on the test streams. If your service level agreements demand 5 nines availability, that redundancy is worth noting. On the flip side, there are practical trade-offs that become obvious once you start configuring the device. RouterOS is powerful, but it's also a different beast compared to the more familiar Cisco iOS or Junos. The learning curve can be steep if you haven't worked with Mikrotik's command line before. The CCR1072 inherits all of RouterOS's feature set, which includes sophisticated firewall rules, traffic shaping, and MPLS, but you'll need to invest time in mastering those modules. For a team that already has deep Cisco or Juniper expertise, the migration cost in terms of training could offset the lower hardware price. Another consideration is storage. The router provides 2 M.2 slots, a microUSB slot, and a couple of USB ports. In the lab, I used an M.2 SSD to host the RouterOS installation and a microSD card for log archives. The performance gain over a plain microSD is noticeable when you enable extensive logging or run a large routing table with thousands of prefixes. The SSD keeps the right latency low enough that the router never stalls. However, if you're planning to run the device as a simple edge router with a few static routes, that extra storage capability may be overkill, and you'll end up paying for features you never use. Now, who should actually buy the CCR1072? If you're an ISP or a data center operator who needs to aggregate multiple 10 gigabits per second links, run heavy BGP sessions, or provide a high-capacity NAT gateway for a large subscriber base, this router hits the sweet spot between raw performance and price. It also shines for research institutions that need a flexible platform for SDN experiments. The multiple SFP Plus ports give you plenty of physical paths to play with, and the 72-core CPU can handle complex packet inspection scripts without choking. Conversely, if you're a small office, a home user, or even a mid-size business that only needs a couple of gigabit Ethernet ports and basic routing, the CCR1072 is likely to feel like buying a race car when you only need a commuter. The upfront cost, the need for proper cooling, the unit runs warm under load and benefits from a well-ventilated rack, and the requirement to understand RouterOS make it a poor fit for those scenarios. In those cases, a more modest Mikrotik CCR series or even a simple edge router would give you the needed functionality without the extra complexity. Let's talk about the day-to-day experience after the initial setup. Once the routing policies,